Welcome to This Explainer. Today, we're jumping right into something I find absolutely fascinating, how AI agents actually reason, plan, and decide their next moves. We hear all the time about AI getting smarter, right? But how exactly does a model take a really complex problem and work it out from start to finish without going totally off the rails? Well, today we're cracking open that black box. We're going to show you exactly how that underlying logic works, all through the lens of structured reasoning patterns. Let's get into it.
So here's our roadmap for This Explainer. First, we'll look at how AI agents think. Then we'll cover the basics of chain of thought and the limits of internal knowledge. After that, we'll dive into the massive React breakthrough, see the React loop in action, and finally, talk about choosing the right AI pattern. Basically, this is the journey of how AI models evolve from simple text generators into systems that can actually solve real-world problems.
All right, part one, how AI agents think. Let's start by looking at the fundamental challenge of building an AI agent.
How do AI models actually figure out what to do next? It's a great question. And to solve this mystery, we really have to look at the three major reasoning frameworks that give these models their analytical power. Because, spoiler alert, it's not magic. It is a highly structured approach to problem solving. Developers have painstakingly refined these frameworks to get the reliable outputs we all use today.
Moving right along to Section 2, Chain of Thought Basics. This is the absolute foundation that all other agent reasoning patterns build upon. Now, what's really fascinating here is that chain of thought isn't actually an agent pattern itself. It's actually just a deceptively simple prompting trick. But wow, it dramatically improves accuracy, especially on things like math and logic puzzles. By literally instructing the AI to, think step by step, you force it to stop jumping to conclusions and instead show its work. It's like asking a student to write out their math problem. This forces the model to process information in manageable, sequential chunks.
So, you can deploy this technique in a couple of ways. First, there's zero shot, which is literally just adding the phrase, "let's think step by step," to your prompt. Just typing that out forces that intermediate reasoning out of thin air. Or you can use few shot, where you actively provide examples in the prompt to teach the model to mimic a specific reasoning pattern. Both of these methods act like a handbrake. They force the model to slow down and actually process its logic.
Look at a standard prompt. It often results in an AI leaping across a chasm to a confident, and let's be honest, sometimes completely wrong final answer. But chain of thought? That builds a staircase. It produces a traceable, step-by-step reasoning trail. And the true beauty here is transparency. Even if both methods arrive at the exact same final answer, only one gives you a debuggable trail of logic. You can spot exactly where things went off the rails.
For example, take a basic math problem about apples. Without chain of thought, the model might just guess wildly, but with it, it breaks the problem down. Okay, step 1, 3 batches of 4 is 12. Step 2, 15 apples minus 12 is 3. Step 3, the correct answer is 3. So tracing these exact steps doesn't magically make the model smarter, right? It just acts as a guardrail, helping the model use its existing reasoning capacity way more reliably.
But what happens when the model hits a roadblock? That brings us to Section 3, the limits of internal knowledge.
Here's the thing. Standalone chain of thought has a fatal flaw. It is entirely trapped in its own head. It relies strictly on internal knowledge. So, if it doesn't know how to look things up and its internal data is flawed or outdated, well, it will confidently follow a path of totally wrong reasoning, with zero ability to self-correct against the real world. Not great.
Which leads us to Section 4. React, or reasoning plus acting. To solve this severe lack of external grounding, developers invented a massive breakthrough pattern.
So, what is React? It beautifully combines that chain of thought reasoning we just talked about, but it adds external tool use in a continuous loop. Think of it this way. This pattern is basically chain of thought plus tool use on repeat. It's an absolute game changer. In fact, it's the secret sauce running under the hood of major production frameworks today like LangChain and the OpenAI Agents SDK.
Okay, Section 5, the React loop in action. Let's actually look at how this loop builds to accomplish a real-world task, like, say, booking a trip.
Imagine you need flights from Austin to Zurich. Here's how React handles it. First, it reasons, okay, I should use the flights tool. Next, the action. It actually calls the tool with your specific dates and locations. Then, observation. The tool returns 3 live flight prices. And finally, it reasons again. All right, I should present the cheapest one as the final answer. It's this precise, continuous loop of thinking, doing, and seeing. That is what allows the model to smoothly navigate the real world.
Now, why is this so important?
because interleaving reasoning and acting actually prevents the model from hallucinating answers when it should just look them up instead. This format is incredibly powerful because it gives you the best of both worlds. You get the transparent, step-by-step logic of chain of thought, but it's anchored entirely in real-world data. It vastly outperforms just reasoning alone or just acting alone on all sorts of complex decision-making benchmarks. Now that we know the primary workhorse, how does it stack up against other options? Let's jump into our final section, choosing the right AI pattern.
Aside from React, there's another fascinating one called tree of thought. The best way to think about this is like a grandmaster playing chess. It considers multiple approaches and branching paths simultaneously before committing to an actual move. It evaluates these super complex what-if scenarios. So it's incredibly powerful, for sure. But it's also incredibly heavy and demanding to run compared to a more linear pattern.
So, when we compare these three side by side, the choice for developers usually becomes pretty clear. Chain of thought is great for pure logic, but it completely lacks external tools. Tree of thought handles massive planning, but it's highly complex and, frankly, costly. React sits right there in the sweet spot for production. It strikes the perfect balance between transparency, real-world capability, and computing cost. That makes it the most practical tool for the vast majority of real-world problems we're trying to solve right now.
Which leads us to the big picture, and a question I want to leave you with. If React makes an agent's reasoning fully auditable and correctable, how will this transparency change the way we trust AI with our most critical decisions? As we can finally see every single step and tool a model uses, it completely rewrites the conversation around trusting technology in our daily lives. Because when you can see the work, you can trust the answer. Thanks for joining this explainer, and keep exploring.